Hello students, how are you? In the previous video of physical and chemical changes, we were discussing about chemical changes. Okay, we talked about what are chemical changes, then we studied the characteristics of the chemical changes, and we studied some examples of the chemical changes. I hope it is clear. We studied the reaction between copper sulfate and the iron. When iron nail was dipped in copper sulfate solution, then what change we observed? We observed that the blue color of the copper sulfate solution changed, and it changed to green color. Why? Because a new substance, that is iron sulfate, was formed. Okay, we discussed that. I hope it was clear. Then we also studied magnesium ribbon was burnt. What was the product formed? The ash that was formed was magnesium oxide, and then we dissolved that ash in water. Then what was the product that was formed? Magnesium hydroxide. Okay, so these were some chemical changes, and also we studied the reaction of vinegar and baking soda, okay, to see that the gas evolved is carbon dioxide. And how do we test that the gas evolved is carbon dioxide? By passing it through the lime water. So what change do we observe? We observed that it turns milky. I also told you the reason that why does it turns milky, because of formation of calcium carbonate. Okay students, so this was what we discussed till now in the chemical change. Now some other important concepts in chemical changes that we are going to study. Okay, a protective shield of ozone. There is a layer of ozone gas high up in the atmosphere. What does that layer do? The ozone layer protects us from harmful ultraviolet radiations which come from the sun. Okay, it means the harmful ultraviolet UV radiations that can cause skin cancer and other diseases that comes from the sun. It is absorbed by the ozone layer. Ozone layer absorbs ultraviolet radiations coming from the sun and breaks down to form oxygen. Okay, ozone is O3 and you know oxygen is O2. Okay, so while absorbing that ultraviolet radiations, ozone breaks into oxygen, means O2. So that's why the breaking down of ozone into oxygen is a chemical change. Why? Because it is a new substance. Ozone is O3, oxygen is another substance. So it is a chemical change. Now what harm there would be if ultraviolet radiations reach the Earth's surface? See, if ultraviolet radiations were not absorbed by ozone layer, they would reach Earth's surface and cause harm to us and other living things. Ultraviolet radiations can cause skin cancer, damage our eyes and plants. Okay, so that's why this ozone layer that is present in the atmosphere is very important. Okay, it absorbs, again what does it do? It absorbs the harmful ultraviolet radiations which come from the sun and protects us from skin cancer and damage to our eyes, etc. Okay, also protect plants also from that. But in this process, ozone, while absorbing the ultraviolet radiation coming from the sun, it breaks down itself to form oxygen, and that's why it is a chemical change, because ozone converts to oxygen. Okay students, so let's move on to another one. Next chemical change is rusting of iron. Okay, in daily life you might have seen that iron object develops some kind of rust. Okay, it gets covered with that red brown flocky substance, okay, that keeps on eroding from it. That is called the rust, but it does not happen so quickly. Okay, it takes time, many years. Rusting is a very slow process. Okay, so let's take a look at rusting of iron. When an iron object is left in damp air, damp means the air that contains water vapor, okay, moisture, for a considerable time, it gets covered with a red brown flaky substance called rust. This is called rusting of iron. During the rusting of iron, iron metal combines with oxygen in the presence of water to form compound iron oxide, and this iron oxide is rust. Okay, so that rust and iron, you cannot say that they are the same substance, it is different. When iron reacts with oxygen and the water present in the atmosphere, then the compound that is formed, that is iron oxide, that iron oxide is called rust. Okay, again, during the rusting of iron, iron metal combines with oxygen and water which is present in the atmosphere to form a compound iron oxide. This iron oxide is rust. Okay, take a look at this equation. Iron plus oxygen plus water gives you iron oxide. Okay, this is the word equation. Fe, now Fe plus O2, O2 is oxygen, water is H2O, gives iron oxide. Iron oxide is Fe2O3. Okay students, iron means Fe reacts with oxygen O2 plus H2O water to give Fe2O3, that is iron oxide. Okay, rust is iron oxide, Fe2O3. Thus rust and iron are not same substance. We have discussed it. Rusting of iron is a chemical change. So why is it a chemical change? Because the rust that is formed is a new compound. You can say see that initially it was only iron plus oxygen and water. These were other compounds, and the product that is formed, Fe2O3, that was another compound. So that's why it is a chemical change. Okay. Now let's move on to the next, that is condition necessary for rusting. The two conditions that are necessary for rusting of iron to take place are: first, presence of oxygen, and presence of water or water vapor, that is moisture. Okay, means if that iron object, any iron object, maybe it be iron rod, iron nail, anything, any iron object that will come in contact with air and water vapor. Okay, because they are present in, sometimes maybe the amount of water vapor may be high and sometimes it may be low. It is called humidity. Sometimes the humidity may be high or sometimes the humidity may be low. It depends on the conditions. Okay, but the two conditions that are necessary are presence of oxygen, presence of water or water vapor, that is called the moisture. Okay students, now what happens here? Iron rust when placed in damp air. What is damp air? Moisture. Or when placed in water. Now damp air also contains water vapor, you know, because it is moisture, moisture is present. Thus damp air alone provides both the things, oxygen and water, required for rusting of iron to occur. Ordinary water also supplies both the things, oxygen and water, needed for rusting of iron. Okay, again see, iron rusts when placed in damp air. So why damp air? Because it contains water vapor and oxygen is present in the surrounding always. Okay, and ordinary water also supplies both the things, that is oxygen and water, that is needed for the rusting of iron. Okay, next, if the air at a place has high moisture content, that is more water vapor, that is if the air at a place is more humid, then the rusting of iron becomes faster. Why? Because you know, more water, more oxygen will be there, then the reaction will be more. Okay, so the rust that will form will be quickly. The rusting of iron is faster in coastal areas, seaside areas, because the air at those places contains more water vapor. Definitely we know that the coastal area, there is more humidity in the air. Okay, so that's why the rusting of iron is faster in the coastal areas. Why? Because air at those places contain more water vapor. Okay. Second, the presence of salt in water makes the process of rusting of iron faster. Thus an iron object will rust much faster when kept in sea water, which is salty water, than when kept in fresh water. Okay. So important things regarding to rusting of iron is: first, the necessary conditions for the rusting of iron was presence of oxygen and presence of water vapor. What happens? That iron object or the iron metal reacts with oxygen and the water present in the surroundings and forms the rust. Rust is iron oxide. Okay, you need to remember this one. Rust is iron oxide, Fe2O3. Okay student. So thus damp air alone provides both the things, oxygen and water, required for rusting to occur, so the reaction takes place. Ordinary water also, because it is made up of hydrogen and oxygen, so it supply both the things and rusting takes place. Two conditions: that the rusting will be faster at a place which has high moisture content. Why? Because there is more water vapor. High moisture means more water vapor. So there the rusting of iron becomes faster. So that's why it is said the rusting of iron is faster in coastal areas, because the air at those places contains more water vapor. Second, the presence of salt in water makes the process of rusting faster. So the rusting or the iron object will rust faster when kept in sea water instead of fresh water. Okay. So till now we studied how does rusting takes place. Okay. Now it is not, you know that it is not useful for us. Is the rusting process useful? No, it destroys the iron object. Okay. So how we can prevent rusting of iron? So the next topic is prevention of rusting of iron. See students, what is happening in rusting? You know, the iron reacts with atmosphere, or I can say the gas, oxygen gas and water vapor present in the atmosphere. What can we simply do if we simply break the contact of iron with the surrounding? Then we can prevent rusting. If the iron object, iron metal is not coming in the contact of oxygen, is not coming in contact with the water vapor, then rusting will not take place, that reaction will not take place. Iron plus oxygen plus water gives you iron oxide. So what do we need to do is we need to break the contact of the iron object or the iron nail or any iron rod with the atmosphere, so that it does not come in contact with the oxygen and water directly. Then we can prevent the rusting. Okay, let's see. When a coat of paint is applied to the surface of an iron object, then air and moisture cannot come in contact with the iron object, and hence no rusting takes place. The window grills, railings, steel furniture, iron bridges, railway coaches, bodies of cars, buses and trucks are all painted regularly to protect them from rusting. You know, these are made up of iron. So what do we do by applying paint? We just break the contact of the substance or that iron metal with the air and moisture, so that air and moisture cannot come in contact with the iron metal. They will not come in contact with, hence no rusting will take place. So it also protects, you can see, it is protecting, it is very important. The window grills, railings, iron bridges, railway coaches, bodies of cars, buses, trucks, all, why they are painted? So as to prevent them from rusting. Okay students. Okay, so first one is rusting of iron can be prevented by painting. Okay, let's move on to the next one. Rusting of iron can be prevented by applying grease or oil. When some grease or oil is applied to the surface of an iron object, then air and moisture cannot come in contact with it, and hence rusting is prevented. The tools and machine parts of iron and steel are smeared with grease or oil to prevent their rusting. Okay, you might have seen when a bike, the service of bike happens or a car happens, then they apply grease on the engine parts. Why? Because it is made up of iron, so that it does not get rust. Also to provide lubrication, also the main function is to provide lubrication, but also grease breaks the contact of air and water with that metal, so that's why rusting does not takes place. Okay, so first point, rusting of iron can be prevented by painting. Second, it can be prevented by applying grease or oil. Third, rusting can be prevented by galvanization. Now what is galvanization? The process of depositing a thin layer of zinc metal on iron object is called galvanization. What did you do? You deposited a thin layer of zinc metal on an iron object. And what does that layer do? That layer breaks the contact of oxygen, again water, with the metal, iron metal surface. Okay, so the process of depositing a thin layer of zinc metal on iron object is called galvanization. How is done? Galvanization is done by dipping an iron object in molten zinc metal. Molten means, yeah, that has been converted to liquid form, melted. A thin layer of zinc metal formed on the surface of an iron object protects it from rusting. Why? Because zinc metal remains unaffected by air and moisture. The iron sheets used for making buckets, drums, dustbins and sheds are galvanized to prevent their rusting. The iron pipes used in our homes to carry water are also galvanized to prevent rusting. Okay students, so is it clear, the galvanization? Let's move on to the next. What is the next? Fourth is, iron is coated with chromium to prevent rusting. This is called chrome plating. Chromium metal is resistant to the action of air and moisture. So when a layer of chromium is deposited on an iron object, then the iron object is protected from rusting. Chrome plating or chromium plating is done on steel furniture, taps, bicycle handlebars, car bumpers, etc. to prevent them from rusting. Okay. So the main objective is just to break the contact of air and water from iron. If you are successful in it, then the rusting will not take place. Okay. It can be as simple as applying paint or grease on it, and it can be a chemical process like galvanization or chrome plating. Okay. Next one is, rusting of iron can be prevented by alloying it to make stainless steel. Now what is a alloy? Alloy is a mixture of two metals. Okay. When iron is mixed with carbon, chromium and nickel, means other elements, this is a metal and these are also some metals and non-metals, chromium, nickel, iron and carbon, when they are mixed, then stainless steel is obtained. Stainless steel is an alloy of iron. Basically alloy is said to be an homogeneous mixture. Okay, a solution that contains solid and solid, it does not contain liquid or anything else. Okay, 2 solids, 3 solids, okay, in the form of that. So then stainless steel is obtained, and stainless steel is an alloy of iron. Cooking utensils, knives, scissors, surgical instruments are made of stainless steel and do not rust at all. Okay student, so the cooking utensils that we use in our homes, knives we use, scissors we use, surgical instruments are used, they are made up of stainless steel so that they do not rust at all. Okay, so what we studied till now, first we talk about rusting, that how does the rusting take place. When the iron object comes in contact with oxygen, water vapors, then it forms rust. What is rust? It is not iron. Okay, it is another substance, new substance that is formed by the reaction. And what is that new substance? That is iron oxide. Okay, then we studied what are the necessary conditions for or required for the rusting. Basic or the most required need is presence of oxygen and presence of moisture. Okay, then we compared the process of rusting where it is faster. For example, I told you where the moisture content will be higher, the process of rusting will be higher. So that's why in the coastal areas the process of rusting is faster. Similarly, in salty water the rusting will take place faster. So if the kept in salty water instead of fresh water, the process of rusting will take place faster. Then we discussed that rusting is not a useful phenomena. We need to prevent, because iron objects get destroyed due to rusting. So we need to prevent it from rusting. Then the prevention of rusting. What did we discuss? We discussed first applying paint, second applying grease. What does this do? Applying grease, applying paint, it breaks the contact of the iron metal with that of oxygen and water vapor. Okay, so in this way simply we can prevent the rusting. Third one we studied galvanization. What is galvanization? Depositing of a thin layer of zinc metal on iron. As we know, zinc metal does not get rusted or does not react with that water and moisture, so it prevents the iron. Then we discussed the chrome plating, that is coating with chromium. Okay, and the last one that we discussed was rusting of iron can be prevented by alloying, means to mix it with other elements like chromium and nickel. So stainless steel is obtained and stainless steel does not rust. Okay, so this is what we have now discussed in rusting. It is a very important phenomenon, students. Okay, the next one that we are going to discuss is crystallization. Crystallization. The process of evaporation is not a good technique of separation, because by evaporation we can separate some substance, but why it is not a good technique? Let's see. First, the soluble impurities do not get removed in the process of evaporation of salt solution. So, the salt obtained by evaporation is not pure. Second, the crystals of salt obtained by the process of evaporation are small and the shape of crystals cannot be seen clearly. Large crystals of pure substance can be obtained from their solutions by the process of crystallization. Okay. So, why we choose crystallization? Because the process of evaporation is not a good technique for separation. And why? Because we discussed just 2 points. The soluble impurities are not removed, and second, the crystals are not clear, they are very small. Crystallization is an example of physical change. The solid particles having flat surfaces, straight edges and regular shapes are called crystals. The process of cooling a hot concentrated solution of a substance to obtain crystals is called crystallization. The process of crystallization is used to obtain large crystals of a pure solid substance from impure solid substance. Very important again. The process of cooling a hot concentrated solution of a substance to obtain crystal is called crystallization. Means first you have to increase the temperature, you have to higher the temperature of that substance or the solution, and then let it cool, okay, to obtain crystals. So, the process of crystallization is used to obtain large crystals of a pure solid substance from the impure solid substance. An impure solid substance usually contains 2 types of impurities: insoluble impurities and soluble impurities. The insoluble impurities are removed by filtering its solution, whereas soluble impurities get removed during crystallization. Okay. Again, an impure solid substance may contain 2 types of impurities, may be insoluble or may be soluble. Insoluble, it is easy, by filtration. If you apply if you filter the solution, then the insoluble impurities are removed, whereas the soluble impurities are removed by crystallization. Okay. Now, let us discuss the process of crystallization. Okay. But it is clear to you, the process of cooling a hot concentrated solution of a substance to obtain crystals is crystallization. Okay. Why it is used to obtain large crystals of a pure solid substance. Impure solid may contains 2 types of impurity, that is insoluble and soluble. The insoluble are removed by filtering its solution, whereas soluble impurities get removed during crystallization. Okay. Okay. Process of crystallization. Impure copper sulfate powder can be purified by the process of crystallization to obtain large crystals of pure copper sulfate. Okay, let's see how. Take about 100 ml of water in a beaker and add a few drops of dilute sulfuric acid to it. Heat the water over a burner till it boils. Add copper sulfate powder slowly to the hot water with constant stirring. Means you have to continuously stir it so that the copper sulfate powder dissolve. Continue to add copper sulfate till no more copper sulfate can be dissolved. This will give us a saturated solution of copper sulfate. Now, what is a saturated solution? Students, the solution that cannot dissolve more amount, means given a fixed amount in a fixed amount of water. The fixed amount of solute that can be dissolved in fixed amount of solvent, that is saturated solution. For example, if I am dissolving sugar in water, then a point will come, if I keep dissolving, then a point will come that the sugar will stop dissolving. Why? Because now it has reached its saturation point. No more sugar or salt can be dissolved in the water. Okay. So, this will give us a saturated solution of copper sulfate. Filter the hot saturated solution of copper sulfate to remove insoluble impurities. Okay. Now, you have to filter it. Allow the hot and concentrated solution of copper sulfate to cool slowly. Do not disturb the solution when it is cooling. After some time, what we will see? We will see large copper crystals at the bottom of the beaker. Separate the copper sulfate crystals from solution by filtration and dry. The soluble impurities present in copper sulfate do not crystallize and hence remain behind in the solution. Okay, students. Again, what did we do? See, we took water in a beaker, then added few drops of dilute sulfuric acid to it. Okay. Then we heated the water and added copper sulfate powder slowly and kept stirring it. Then we continued to add copper sulfate till no more copper sulfate is dissolved in it. That is, a saturated solution of copper sulfate is obtained. Then what we did? We filtered the hot saturated solution of copper sulfate to remove insoluble impurities. Okay, now the insoluble impurities are removed. Now the thing remains is soluble impurities. Now that hot and concentrated solution of the copper sulfate is allowed to cool slowly. Okay, it is not disturbed during when it is cooling. Then after some times, what we see, that the large copper sulfate crystals at the bottom of the beaker. We separate the copper sulfate crystals again by filtration and dry them. The soluble impurities present in the copper sulfate do not crystallize. Okay, only the copper sulfate crystallizes to form the crystals, and hence the soluble impurities remain behind in the solution that will you get after filtration. Okay, so you get copper sulfate, pure copper sulfate crystals away from the impure solution. Okay students, so I hope the process of crystallization is clear to you. This concludes the chapter. This is the end of this chapter. Go through the videos of this chapter again. Okay, study it, make your notes properly. Okay, and learn it. In the next video, we will be discussing the solutions of this NCERT exercise of this chapter. Okay, till then students, stay inside our house, keep studying and take care of yourselves. Okay, thank you.